Yes, sir.
See students, today we will discuss ions in aqueous medium, means water. This aqueous medium means we need to talk about the water. Let us understand today water means exactly what. How does water behave? And then ions in water you will understand. Let it be the acid aspect means H plus ion or OH minus ion. From where are they coming? They are coming from the water. I come to that point. But before that, let us understand the water in true sense. I want to know from you water is liquid means H2O is liquid at room temperature. Why? Because if you consider elements from the same group, oxygen is above, below that sulfur is there. Oxygen can combine with two hydrogen, H2O or OH2. Sulfur can combine with two hydrogen, SH2 or H2S. This H2S is gas while H2O is liquid. That's my question. Why H2O is liquid? Will anyone help
Due
me?
to hydrogen bonding.
Right, right. Due to hydrogen bonding. Means what happens there? This oxygen remains in connection with hydrogen of other water molecule and that remains in continuation. Similarly, this hydrogen also is in connection with other water molecule. You can see here as oxygen. This also is in connection with the other oxygen. So those are linked to each other. Those are related to each other. Those have affinity with each other because of gathering, because of coming closer. Those molecules or that species, that matter remains in liquid form. Gaseous form means more separation. Liquid means separation is less. Solid means separation is further less separation will be there. It is a general understanding of the state. Means solid, compact, liquid, less compact, gaseous, free, or further very less compact. Compactness considerably decreases in gaseous phase because of hydrogen bonding. Why is that hydrogen bonding? Because oxygen carries partial negative charge and hydrogen carries partial positive charge. Maybe that's a half positive charge. So that because of that negative and positive interaction, it is not perfect. It is ionic interaction only. But we are not saying it as a ionic bond as strong. It's a somewhat related to electrostatic force of interaction, related to ionic interaction, but label specifically is made that's a hydrogen bonding because of the existence of the hydrogen. And due to this linkage, because of this polarity, unlike poles attract, water molecules do associate, and because of their association, a compactness increases, and because of the increase in compactness, in spite of the gaseous phase, we find a liquid phase forward the water. Students, are you understanding why water is liquid at room temperature?
Yes, sir.
Yes,
Yes.
sir.
Is solid form of water possible? Is solid form of water possible?
Yes.
What
Yes,
is that?
sir.
What is that?
Yes, sir.
What
I
is right? Whatever we say ice is solid form of water. Vapor, water vapor that we say is a gaseous form of the water. Water is a chemical I am saying. In literature means point of view or commonly what we say water means liquid only. It is just our conventional way. Scientifically chemical point of view H2O is a formula for ice. H2O is a formula for liquid. That's a water. That generally we say. And H2O is a formula for vapor. That's a gaseous water. Formula is same. Chemistry is same. So in general point of view, what we think solid are more compact. So what do you think? Ice and liquid water. If you compare, who is more compact? Liquid water and solid water. Who is more compact? Compact means close, associated, more associated business. Associatedness is there. Who is more compact? Compactness means
Solid.
solid is more compact. Means ice is more compact. Am I right? Are you following what I'm saying?
yes, sir.
Yes, sir.
Yes.
This solid is more compact that you are seeing. Now I ask you the question. What is your observation? If you put ice piece or ice cube in water, that ice cube goes down or ice cube floats. If you take a water in a glass or the beaker and index of
Floats.
yes,
Float.
yes, ice cube floats. Means actually major portion remains in the water, but it remains upside. What does it mean? Whose density is more? Density of water is more or density of ice is more? Means it's a liquid and it's a solid. Whose density is more? Suppose if I take a water in a beaker and in that if I add oil drops, then oil drops also will float. So we say that oil is of less density. So that question is mine. Solid water is denser or liquid water is denser? Who is more denser?
Liquid water.
Yes. So density of liquid water is large or density of ice is less. What is density? Density means mass upon volume. If this mass increases, means that volume remains same. If mass increases, density will increase. Or mass remains same, volume increases, density will decrease. So one thing I have to keep constant. So let me say this mass, one particular quantity of water, 18 gram of water, 30 gram of water, 50 gram of water, particular mass only I am taking. 50 gram of water, its volume, how much it occupies. We can measure in terms of cubic centimeter or dm cube. And 50 gram of water and its volume in solid form. Solid volume also we can measure, no? Suppose in cubic form, then a cube side raised to 3. That is the volume for that side. That's a cubic crystal. So my question to you is, you said that ice is less denser means if particular quantity of solid is taken, then volume of water is more or ice is more. Who will govern more volume? Particular quantity, 50 gram of water, mass is constant. Whose volume will be more, for water or for ice? Yes, are you understanding what I am saying?
Yes, sir.
You know that density of water is more. My question is, whose volume will be more? Okay, I ask you other question. Suppose if you take one bottle, say glass bottle or plastic bottle, in that if you fill water, complete, proper filling, perfect filling, water filling, and if you keep that bottle in the freezer, and if ice obtains, have you noted any time that bottle cracks if there is no chance of expansion? Or suppose if that lid is not loose, some space is available, so then ice whatever you obtain that remains with complete region, means little portion you have kept blank, water was not there, but when you measure the and take a ice is full pack. Or have you noted ice cubes, a tray remains, you are filling the water up to maximum what, up to the highest limit of that the container, that's a tray, cube is there, no height limit. But when ice forms, that's the ice remains somewhat upside. Have you noted that?
Yes, sir.
Yes, sir.
So then answer for my question, whose volume is more for particular quantity, for particular mass? Water volume will be more or volume of ice will be more?
Volume of ice.
Yes, volume of ice is more. Volume is more. So density will be less. So that you have answered there. Ice density is less. Therefore, ice floats on what? The water. So compactness, whatever the word at the beginning I use, now maybe you are thinking about that word. What exactly the compactness? Compactness is a rough word because in compactness particular quantity was not defined, no? So but that is defined in density. So now if I ask, if I take 50 gram of water, it occupies one volume, and if I take 50 gram of ice, it will occupy more volume. Then who is more compact? Ice is more compact or water is more compact?
Ice.
Ice is more compact. Okay, that's the see, that's a legacy of our basic concept. My simple question is, one particular entity is there and that is occupying one volume, say x. Same entity occupying volume y, that y is larger. Then when it occupies volume y, then it is a more compact, or when it occupies volume x, that's a more compact. Compactness means closeness. Water is more compact or ice is more compact? Water means liquid water, I'm saying.
Liquid water is.
Are you understanding? Because you have already answered that ice is more compact, and actually I not accept. I wrote only that answer, and you were happy. Okay, your answer is correct. Actually, I am thinking on that answer now. Therefore, I had given you the explanation of concept of density, and then you said that ice has a less density. Now I am asking to you: is ice more compact than water? Could you able to understand what I am saying?
Repeat, sir.
Okay, I took one container, and in that container, suppose one particular quantity of water is there and its a level is up to here. Here water is there, particular quantity. Say the quantity of this water is 50 gram. Afterwards, what I did, I kept that container in freezer and then it obtained ice, and that ice is occupying more space. It is expanded. Quantity is 50 gram only. Question is, who is more compact? Compact means molecules are closer.
Ice.
Ice is more compact. Okay. Any other answer? One more example I give it to you. Sponge you consider sponge. Sponge has particular volume. And then what you do? Small pieces of sponge are there, no? Remove them. And you will get one volume. Which volume will be more? Small pieces or one particular large piece of sponge? Could you able to understand my question?
Yes, sir.
Then answer.
Large sponge.
One large sponge will be one sponge, small pieces sponge gathering will be the more volume, or one particular that sponge will be more volume. Means while traveling in ST as a sponge remain or other way. So many would find that they remove that sponge. One particular sponge you have taken and you have broken that sponge, broken that same quantity sponge, and you kept broken sponge, deflagrated sponge, dispersed sponge will occupy more volume, or one particular sponge will occupy more volume. Great. Okay, I will ask you one more question. Take any grain and grind that grain. Flour you will get, the flour. So when you carry the grain, suppose one container is there, and in that you are carrying the grain particles. Small grain particles are there. Its volume is in this way. After grinding, that volume will increase or decrease?
Increase.
Increase. Here particles were there, no large particles. They will occupy some volume. After grinding, after getting flour, that volume will increase or decrease?
Decrease.
Decrease. Don't go on my questioning. It's a practical observation. At least you should observe it properly. Is my example clear? Grinding mill, do you know? Flooring mill, do you know? That flooring mill, if you carry that your grains after grinding, you will get the flour, and that flour will occupy one volume. That volume will be less or more. That will decrease in volume or increase in volume after grinding. Horrible students. So what's your observation then? Are you science students? It's a question now. I'm not understanding where is the problem. You don't want to answer, therefore you are not answering, or you don't know, therefore you are not answering, or you are not understanding what I'm asking. Yes, clarity I want there. Yes, Siddhi, what's the problem? Siddhi, Gitanjali, Shilpa, Shubham, Prathamesh, Shivani. What's the problem? Where is the problem? Whatever I am asking, are you not understanding, or you are not interested to answer? Let me know now how many of you are here. Yes, Siddhi, what's the problem? Yeah, you have answered, but now this question now, whatever I asked, no, about the floor, you have answered. Decrease or increase?
Yes, sir.
What is your answer?
Decrease.
Decrease. Okay. Siddhi, what's your answer?
Decrease.
Gitanjali, what's your answer? Siddhi, decrease for what? What decrease you are seeing?
After grinding.
After grinding, decrease will be there. Gitanjali, Shilpa,
Decrease.
decrease. Shubham,
Decrease.
Prathamesh, you said decrease. Okay, Prathamesh. Shivani, yes, Shivani, are you there? What's the answer? Yes, Shivani, I am waiting for your answer. If range is not there proper, then you can send the text message. Chirag, what's your answer?
Decrease.
Saurabh,
Decrease.
Mandar, I want scientific observation. You might have went to take other. If you have not went to grind or to get a floor, and then also it's a problem. Is what are you doing? Mandar, I want answer. Gitanjali, Shivani, I think replied. Aishwarya, what's the answer? Aishwarya, are you there? Okay, Mandar replied decrease. Joinita, what's the answer? Do you know the question?
Decrease.
Decrease. Joinita, what's the answer? Joinita also said decrease. See, everyone, each one from your class is saying it is a decrease. It's so horrible. Saurabh now, okay, just I had not asked Saurabh. Okay, Saurabh is saying increase. Yeah, Shubham is saying increase now. Actually, increase is a correct answer. See, what are your observations then? We have not noted the freezing of water. You have not noted a grinding of the grain. Then what are you doing? Such many observations you will find here and there. Even for the other grains, for grinding, or even sugar also if you take, and sugar if you crush, if you grind, weight will be same because same quantity you are taking, but total volume occupied will what the increase. Means scientific observation is not there. See students, nobody will teach you that. You have to do that. That temperament you should be with. If you are not learning and if you are not growing, if you are not remembering the science, if you are finding difficulty, then the problem is here. Your understanding is not there. Just wait, student. You are not understanding the basic. Now you observe that. exactly observe while grinding what happens. Suppose a 2 kg, 3 kg, 4 kg, 5 kg through the container, maybe the bag, any bag or this metallic container through which you carry to get a floor. And after getting floor, you will find its volume increases. When you freeze the water in the bottle, you will find volume increases. So my point of interest here is the water. Yes, students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
So problem main is there towards your approach to the study. Lot of development you need to do. Don't take it negatively. A proper spirit to know things and go on observing things, you will find that volume of the after grinding will be larger. Means what? The grain is more compact. It depends upon the distance between the two grains also. It is not applicable for chili. So chilies are taken and after grinding, the powder becomes small because too much space is there, no? But about grains, what? They are heavy, they are compact, nearby, near to each other. By the way, within them, whatever the compactness is there, within that grain, after grinding, that compactness goes. The grain is more harder or that floor is more harder. What do you think?
Grain is harder.
It's a general. Grain is more harder, hard point of view. This is a compactness point of view. Compactness point of view. So density, if you see, density of the grain will be larger. Density is what the larger. So density is a proper term. My point of interest is water. A liquid water and solid water. We found the density for liquid water is more than solid water. Means in true sense what? In true sense, liquid water is more compact. Surprising. Therefore, I said, let us today understand water. How is it? Liquid water is more compact than solid water. It seems it is hard to touch. Hard to touch, it doesn't mean that it is more compact. As like for grain, one logic I had given. It's a scientific development. So once you know any logical thing, you have to go on applying. Go on applying. It is an interesting thing. Then you will learn the science more and you will grow in the science. And you can grow that science. So liquid water is more compact or rather than proper word is denser than solid. Therefore, ice floats on water. Why ice floats on water? Because it is less denser than that of the liquid water. It is difficult to digest, but it is the anomalous behavior. It is a different behavior, spatial behavior of the water. Are you understanding what I am saying?
Yes, sir.
Yes, sir.
Yes. Then question further arises why ice is less denser than water? Why ice floats on the water? That question arises. Hydrogen bonding is there, compactness. What happens? That bond is like a spring. Bond is like a spring. So up to particular limit, that is a compression. Okay. But afterwards, when you force that, that spring will expand. Means actually force means you don't press, but up to particular limit. Afterwards, there is expansion. It's called a tetrahedral. That's the arrangement, and it is found due to hydrogen bonding only. Hydrogen bonding in solid form means as temperature decreases, considerable decreases, it is found the water molecule and other water molecule distance will increase. Then question arises, is that logic wrong that if we decrease the temperature, compactness will increase? No, it is not wrong. Now, if you consider water at room temperature, say 25 degrees Celsius room temperature or 30 degrees Celsius. Now, so cold is there, so timing consider 25 degrees centigrade. So water at say 25 degrees Celsius. You cool that water, make to 20 degrees Celsius. Further cool that 15 degrees Celsius, 10 degrees Celsius. Likewise 5 degrees Celsius or I make it 4 degrees Celsius. So what will happen? Compactness or density will increase up to 4 degrees Celsius. Afterwards, more than that water cannot come closer. There is a limitation not to come closer also. Cannot come closer. But still, ice is not formed. Solid is not formed. Solid occurs at 0 degrees Celsius. Means considering standard conditions. So after 4 degrees Celsius, what happens? If they try to come closer, that much away they will go. Try to them come closer, further away they will go. 3 degrees Celsius away, density will decrease. 2 degrees Celsius, they'll go away. Density will decrease rather than increase. 1 degree Celsius, further decrease. 0 degree centigrade, further there will be decrease in the density and ice will be result. And due to hydrogen bonding and due to anomalous behavior, due to this 4 degrees Celsius as the critical temperature, important temperature, we find ice floats on water or its density is less than that of the water. Whatever I am saying, could you able to understand?
Yes, sir.
Yes, sir.
Yes. Now tell me, what's the formula of water?
H2.
H2O. How we represent the structure of the water? Oxygen, hydrogen, hydrogen, and here we represent the lone pairs of electrons on oxygen. Actually, geometry point of view, structure is tetrahedral. Geometry point of view. It's a distorted tetrahedral. Perfect tetrahedral it is not, because lone pair repulsion. Last year this CPR theory you all studied. Lone pair, bond pair repulsion, and total repulsion. In order to get a minimum repulsion, a structure will be there. A structure or geometry is what tetrahedral. But shape, if I have to answer, then I have to consider molecule, and that shape is angular. Means I like one angle you represent. Likewise, in this way. So that is our water molecule. It is one angle. Therefore, we say a shape is angular. Doesn't matter whatever the shape it may be, but electronegativity difference is there. Oxygen is more electronegative than hydrogen. So what will happen? Oxygen will contribute. What are these 2 electrons are there? Here 1 electron, 2 electron. That bonded pair will be contributed more by the oxygen. It will belong more to the oxygen. Because of that, oxygen will bear one negative charge, partial negative charge, delta as one number, random number, term that I am using. Delta minus negative charge. If oxygen has negative charge, then in order to balance that negative charge, there should be positive charge on one hydrogen. It is delta plus. It is delta plus. Is it correct?
Yes, sir.
It is not correct. See, delta minus is a charge on oxygen. Delta plus is a charge on one hydrogen. Delta plus is a charge on other hydrogen. Do summation, total. What's the answer? Summation of all these. What should be the answer? No, students, at least you should reply. Delta minus is one term. Plus delta plus. Plus delta plus. What's the final answer?
Delta plus.
Right, delta
Delta
plus.
plus.
Delta plus. Am I representing delta plus charge on the water? No. Water molecule has no charge. Means whatever the answer that I received is wrong, or whatever I represent here is wrong. I have to change that. So what change will be there? Here delta plus, okay. What will be the charge on hydrogen? That's my question. Here delta plus is represented. What will you suggest? It should be
No
okay.
charge.
Yes. Here what will be charge? Tell me now. On this hydrogen, what will be the charge?
No charge.
Hydrogen. How? Because oxygen is electronegative, no? Oxygen is electronegative. So oxygen is taken electron towards itself, and because of that more richness of electron, it's not a complete property of oxygen. If only property of oxygen would have been there, it's no charge. But it has given that property. Sorry, it has taken the property from hydrogen, extra property added, electron cloud added. Therefore, negative charge on oxygen. If oxygen is taken, it means who has given? Hydrogen has given. And because of giving the electron, not complete transfer, just sharing, unequal sharing. Because of giving the electron, hydrogen will be with positive charge. But how much positive? This hydrogen is with half positive. I want answer from you. What should be the charge on this hydrogen? So that water will be with no charge. Delta minus plus half delta plus how much should be there so that you will get answer here at 0. What should be the charge on hydrogen? Somewhere problems are there. I am not understanding where I am wrong or my strategy is wrong. See, again I ask the question. Oxygen, hydrogen, it is our structure of water molecule. I told you this oxygen carries minus charge. Say it is a delta minus. If oxygen carries minus charge, then certainly these hydrogens should carry plus charge to cancel that minus charge. Why? Because a lone water molecule has no charge or 0 charge on water. If there is a 0 charge, then what are the internal charges are there? Those are to balance. So to balance those charges, what I did, charge on one hydrogen and represented as half delta plus. Now my question is, what's the charge here? What shall I write here now?
Half.
Half, complete that half.
Delta plus.
Right,
Delta plus.
half delta plus.
Delta
It is the polarity of what the water. Polar separation means from outer sense you feel that neutral water molecule, but within that water molecule the problems are. Within that water molecule, uniformity is there, unequal separation is there, unequal electron distribution is there, partial charge separation is there, charge allocation is there. So how are the charges that I informed to you? Is that charge separation and charge distribution for water clear to you?
Yes, sir.
Yes, sir.
Yes. So water at room temperature is in the liquid form, and water, greatness of the water, it is called as universal solvent. Too many things are there which do dissolve in the water. And chemistry, whatever you are studying at this moment is aqueous chemistry. Means whatever titrations you perform, reactions you perform, those reactions in the aqueous medium. I am not saying only water is a medium. Other solvents are there. At this moment, our restriction is towards the aqueous medium. That's water. It is a universal solvent. It is a best solvent for many compounds. So how will they behave in the water? To know that, we should know water first. Now I ask you the question. Suppose if I take water in a beaker. Formula for water that you have suggested, the formula is H2O. My question to you is there any ion present in the liquid water? Is there any ion? Ion means what? Calcium plus 2, magnesium plus 2, sodium plus Cl minus, SO4 minus 2, O minus 2. These are the ions. Such ions, or here H plus or OH minus. These are the ions. My question to you is, in this water in a beaker, we represent formula as H2O. Question is there any ion?
Yes.
Okay, answer is yes. What about others? I had not added any acid there. I had not added any base. I had not added any salt. Only water. Pure water. Water I am discussing is a pure water. And question is there any ion? Answer is yes or no. Further 3 replies I want.
yes,
Further 2 replies I want. Question is, pure water in a beaker or container, does it remain with any ion? Further 2 students reply I want. You are 12 students and I got only 3 replies. I want further 2 replies. If question not clear, say question not clear.
Yes.
Okay. Further reply. Saurav also replied. Further reply. Joined also replied. Yes. Okay. See students, you have to talk. Yes. There will be ions. Now answer from a question. Which ions? If you are saying that water is with ions, then which ions?
H plus and OH minus ion.
Brilliant. 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 Okay. I am happy to know now. Such a performance I want. H plus plus OH minus. These ions do remain. Means what? Whatever may be the temperature, whatever may be the other where from where the water it may be, water will undergo ionization, dissociation, but it is in particular manner. What are the number of H plus ions are there? Equal number of OH minus ions will be there. If H plus ions are X, OH minus ions will be X. So from that one term came that is called as Kw. Yes, what is Kw? What is Kw? Have you heard this term Kw? Ka dissociation constant for the acid, Kb dissociation constant for what the base, Kw.
Dissociation constant for what?
Yes, dissociation constant or ionic product. Concentration of H plus ion and concentration of OH minus ion. More correctly, we represent this H plus as H3O plus. H3O plus. And here instead of only one water, we consider 2 water molecules. And we get H3O plus and OH minus. It is an actual dissociation or ionization reaction for water. This Kw is a dissociation constant. Will anybody answer what is the value of Kw? Anybody knows? Kw is equal to 10 raised to
Minus 14.
Brilliant. 10 raised to minus 14. So Kw is equal to 10 raised to minus 14. Then what will be the concentration of H plus ion? That reaction I represented, no? H2O provides H plus or H3O plus ion and OH minus ions. What is their concentration? If it is X, it also should be X. Two H2O molecules, then H2O plus. If only have one H2O, then H plus will be there. If its concentration is X, it should be X. Kw means product of concentration. X square is equal to 10 raised to minus 14. Then what's the value of X? That's my question. 10 raised to
7.
minus 7. What is the concentration of OH minus ion?
-7.
Right, minus 7. This is minus 7 plus minus 7 is minus 14. So therefore, what we conclude, pH range. pH varies from 0 to 14. Why? Because water has solubility product 10 raised to minus 14. That minus 14 number. Because of that, maximum pH is 14. I'm not talking about empirical pH. Maximum pH is the 14. So 0 to 14 is a scale. That's the pH scale. So 0, if you consider here, I represent that. 0, 1, 2, 3. Likewise, 12, 13 and 14. What will be the central value? Middle value. Central value will be
7.
7. Therefore, we say pH of neutral solution, neutral medium, neutral solvent, say water. Other things are not added. Pure water is there. pH will be what? 7. If pH is less than 7, we will say it is acidic. If it is more than 7, we will say it is what? The basic. It is because the OH minus ion concentration will increase. It is because H plus ion concentration will increase. In other words, OH minus ion concentration will decrease here. H plus ion concentration will decrease here. Increase in OH minus we are seeing as a basic, or decrease in H plus. Increase in OH minus, it doesn't mean H plus are not there. Basic solution, it doesn't mean H plus are not there. They are there to less extent compared to OH minus ion. So result is the OH. Conquering is by OH minus ion. In case of acid, H plus ions are there. It doesn't mean OH minus ions are not there. It is an interesting concept of equilibrium. And that equilibrium reaction is this one. It is a dissociation reaction, ionization reaction. It is called as autoionization or self-ionization reaction. And the self-ionization reaction is very important to understand chemistry of water and chemistry within water. Yes, are you understanding what I'm saying?
Yes, sir.
So today conclusion, finally what we sort out, conclusion is pH varies from 0 to 14 and pH of water is 7, is a medium. Why 7? Is a middle position. 0 to 14, middle is 7. Equal concentration H plus and OH minus ion. That is neutral. And again, acid means H plus ions, dominant, predominant. It doesn't mean OH minus ions are not there. Bonding means attraction. It doesn't mean repulsion is not there. Friends are there. It doesn't mean they don't have the repulsion or they don't quarrel. Will be there. But most result is that dominant result is what? Friendship. Okay. Or the bonding. Yes, students. Let us sum up now. I started a discussion with the title of the topic and I highlighted only on this aqueous, means the water medium, and we tried to know this water. Why water is liquid, that I answered. I asked a question about compactness and about what the density, and then different examples were given, and we concluded that grain, if you grind, then the volume will increase, so compactness will decrease. Then for water, we concluded density of liquid water is more than that of the solid water. Though solid feels hard, ice feels hard to touch, but from density point of view, it is what? Less. Therefore, ice floats on the water. Then why ice floats? Because of less density. Why it is of less density? Hydrogen bonding. Then how actually the variation occurs. And among water, water at 4 degrees centigrade, maximum density, more density. After 4 degrees centigrade, cooling I am talking about. If you reach to 3, 2, 1, density will go on increasing, and at 0 degrees Celsius where ice forms, density will decrease. And so ice can want the float up to 4 maximum. It's a specialty of water, anomalous behavior of the water. And then I told water undergoes. Actually, you said ions are in the water. Yes, because of that we say ionic product of water, ionic constant of the water, equilibrium ionic constant for the water, 10 to minus 14, due to which we get the value 10 to minus 7 and 10 to minus 7 for H plus and OH minus concentration. And last we calculate pH range at 0 to 14, and middle is what the, because of the 10 to minus 7, 7 pH or 7 pOH we consider as a neutral medium. Yes, students, whatever I discussed today, is it clear?
Yes, sir.
Yes, sir.
Any question? Any doubt?
No, sir.
Shall we stop now? Okay. Okay, students. So I declare here the session is over. For next lecture, remember, assignments will be there, videos. By the way, you have to go through the textbooks. You can come in the college and take the book from the library. I'm not saying only tomorrow you have to come. Whenever the work is there, or you have to find that day, or if practicals are there, you can work. And before the next lecture, you have to study. What you have to study? Why cations are acidic. Cations are acidic in nature. H plus is one of the cation, but I'm talking about other cations also. Cation may be acidic. Why it is acidic? That you have to study. You can go through internet and find it. Question, answer for the question. Why cations are acidic? And which factors are there that determine their acidity. So cations in aqueous medium, that point you search there on the Google. So Google media you use, or print media, books you can what use, but you have to study up to next lecture. Is it clear?
Yes, sir.
Yes, student. Then I stop the discussion here, and I stop the recording also later on, and I declare here today's session is over. Quit now.